Welcome back. Now, we'd like to take our analysis of the overlap delegate into C++. Now, let's take a look at BP item again. And here's on component begin overlap. And notice the third line in the pop-up. It says, for events when objects have a blocking collision, for example, a player hitting a wall, see hit events. So we know that there are overlap and hit events. We're going to take a look at overlap events, but they work in very much the same way. So we're going to delete these nodes here, as we're going to take a look at C++ now. Now we added this sphere component here in Blueprints, which means we can select it and hit the delete key to remove it. We're going to add a sphere component in C++. So let's go ahead and hop back into Visual Studio. And here in item.h, I'd like to add a sphere component. Now here's the documentation for use sphere component, and we have the include right here. It said components/sphere component.h. Now use sphere component will need to be forward declared. So we'll forward declare it up here at the top. We'll say class use sphere component, and now we can use this type to make a variable. And we'll make this a private variable. So we'll go down to the private section just under item mesh and declare a useSphere component pointer and call this sphere. Now I'm going to make this a uProperty with visible anywhere. I'll go ahead and add that there. And we need to construct this in the item constructor. Now I can hold Control on my keyboard and hit KO, and that'll open my CPP file from the .h file. And here we're going to need to include the type we're going to use. That's our sphere component header file, so we can copy this include line from the documentation and paste it right there. And right here in the constructor, we're going to construct our sphere. So we're going to say sphere equals, and we'll use create default subobject with use sphere component, and our text macro can simply say sphere. And I'd like to attach this to the root component, so we'll call sphere setup attachment, passing in our root component. I'll use the getter get root component. So this creates the sphere. And as we mentioned, the sphere inherits from uPrimitive component, and the primitive component type has all these delegates, including on component begin overlap. I'd like to take a look at the primitive component header file to see what those delegates look like. So in the Solution Explorer, I'm going to search for primitive component.h and double click that header file to open it up. I'm going to search for on component begin overlap, and it takes me to this line here. Now notice these are all macros, and they all say declare dynamic multicast sparse delegate, along with a number of params. Now, this is quite a mouthful, but this macro here is built into Unreal Engine, and it's used to create delegates. Now, the delegate creation system is quite sophisticated and advanced. To understand it, we would dive deeper into engine code, but we really don't need to do that. We can take this as a sort of black box as long as we understand how it works. When using these large macros, a number of inputs are passed into them, and this allows Unreal Engine to create the delegates behind the scenes. Now, I'd like to look at this second one here and sort of analyze it. Now, the first input to this macro is fComponent begin overlap signature. This is essentially declaring a new type called fComponent begin overlap signature, and it's specifying that this delegate is associated with uPrimitive component. And after those first two inputs in the parentheses, we have on component begin overlap. Now this is the name of the delegate. The first input is the type. The second is the name of the delegate. It seems confusing, but this is how a new delegate is declared. Now following this, we see that there are a number of other inputs, and they alternate between types and names. Now this is what determines the type of callback that can be bound to this type of delegate. The callback has to have a number of input parameters, the first of which needs to be a uPrimitive component pointer called overlapped component. The second input needs to be an aActor pointer called otherActor, and so on. We can see the rest of the inputs there. So looking in uPrimitiveComponent, any of these delegates that belong to primitive component can be bound to as long as we create a function that has the correct function signature. It needs to take these specific inputs. So what we're going to do is make a function capable of being bound to the onComponentBegin overlap delegate. And we're going to do this in item.h. So I'd like to make a function, and I'm going to make it protected. So here in the protected section, we'll declare a new function. It's going to be a void function. And really, we can call this function anything we like. I'm going to call this onSphereOverlap. And we're planning on binding this to the onComponentBegin overlap delegate on a primitive component, specifically our sphere component, as it's derived from uPrimitiveComponent, so it has that delegate. And we need these inputs to be compatible with that delegate. So that's why we can go to primitive component and take a look at the declaration for this delegate of this type. So after onComponentBegin overlap, that's the name of the actual delegate, the rest of the inputs are going to tell us what input parameters our callback function needs to have. Now, the types and the names are separated, which means we have an extra comma here in between types and names. We'll need to remove that, but that's okay. We can copy the rest of this list all the way to the end, just before those closing parentheses. We can copy this and go back to item.h and paste them in here. And what we need to do is remove the commas between the type and the name of these inputs. So we have uPrimitiveComponent, comma, we need to remove that comma, and this is our first input parameter, a uPrimitiveComponent pointer called overlapped component. After that, we have an aActor type, followed by the name of that input called otherActor. So we need to remove the comma between the aActor pointer and otherActor. Next, we have another uPrimitiveComponent called otherComp. We'll remove the comma between type and name. After that, there's an int32 called otherBodyIndex. We'll remove the comma there. Next, there's a bool called bFromSweep. Removing that comma, that leaves us with the final input parameter, a const fHitResult reference called sweepResult. Now, this is passed in by const reference for a couple reasons. It's a reference because this allows us to pass in an input parameter of type fHitResult without making a copy. That's how references work as input parameters. They pass in the actual value of the input, so it's a lot more efficient as there are no copies made, but passing in by reference is dangerous because if we were to change the value of this input inside the function, it will change the actual variable that was passed in. That's why there's const here. With const, the actual value cannot be changed inside the function. So we get the benefit of being efficient, avoiding making copies, but the safety of not being able to change that input parameter. So const references are a great way to be efficient and safe. Now let's add our final semicolon there. And we now have this function capable of being a callback bound to a primitive component's onComponentBegin overlap delegate. So now that we're finished taking a look at primitiveComponent.h, I'm going to close out of it. Now we plan on binding onSphereOverlap to a delegate, specifically a dynamic multicast delegate. Now we'll talk more later about what those things mean. But to bind a callback function to a dynamic multicast delegate, it has to be exposed to the reflection system, as this type of delegate is capable of being exposed to blueprints, and we can have events bound to those delegates. That's why we had an onComponentBegin overlap event in blueprints, because this is a dynamic multicast delegate. Now, any functions we bind to it have to be U functions to be exposed to the reflection system. So onSphereOverlap needs to have a U function macro. This will ensure that we can actually bind this to the delegate. Now, let's make a function definition for onSphereOverlap. So here we have it, onSphereOverlap. Now, just like that event, onSphere overlap will be called in response to an overlap event with our sphere component. If something overlaps with it, this function will be called in response. The delegate will loop through its delegate list and call any callback functions bound to the delegate. Now, we haven't bound it yet. That's what we have to do next. But before we do so, notice, once this function gets called, it has all these input parameters. When the delegate calls this function, it will pass in information about that overlap event, and when our callback gets called here in item.cpp, we can use that information. We can see what the other actor was, what the other component was. We can check and print the names of those. Other body index allows us to know which physics body was hit or overlapped. Physics bodies are related to an asset known as a physics asset. Whenever we showed collision while playing in the editor, we saw all those capsules surrounding various body parts on our character. Those represent physics bodies. We also know if the overlap event was generated as the result of a sweep. We haven't gotten much into sweeps yet, but this tells us if that was the case. And we'll learn more about sweeps, don't worry. And if there was a sweep, we get this data structure called an fHit result, which tells us information about the point at which the overlap occurred, such as the location in space, and so on. So we have a number of inputs that give us information about the overlap event. We're going to take advantage of that when we implement some functionality here, but we do need to bind this callback to the delegate on our sphere component, and we're going to do that in begin play. It's too early to do this in the constructor. Begin play is where the game actually starts, and by then, everything is fully initialized. So we're going to do it here. And here's how we do it. We take the primitive component that has onComponentBegin overlap. That's going to be our sphere component. And we access that delegate. It's called onComponentBegin overlap. And onComponentBegin overlap is an fComponentBegin overlap signature, as we saw in primitiveComponent.h. This is its type. And this type is going to have a number of functions and macros. In order to bind a function to this delegate, we use addDynamic. And IntelliSense will pop up this version underscore internal addDynamic. Now, I've seen this in the past few versions of Unreal Engine. IntelliSense doesn't seem to know about addDynamic, but that's the one we're going to use, and it works. And once we hit the opening parentheses, we do see that this function macro takes 2 inputs. Now notice I use the dot operator, not the arrow, because onComponentBegin overlap is not a pointer. It's actually a regular variable. So that's something to be aware of. Now let's talk about these 2 inputs. The first is user object. Now this is the object that has the callback function. That's going to be this particular object that we're in. And user object needs to be a pointer, so we can use this, which is a pointer to the object we're in. And the second input is the callback function itself, specifically the address of the callback function. So just like we did in setUpPlayerInputComponent for the pawn and our character, we needed to use the fully qualified function with the address of operator. That way, we can pass the address of the function. That's how we can bind it to the delegate. So we're going to take our fully qualified function name, aitem : onSphere overlap. We're going to copy that, and we're going to pass that in to addDynamic right there. This is how we bind a callback to a delegate. Pretty simple. So on begin play, our callback will be bound to onComponentBegin overlap. And now we can do something in response to an overlap event, such as print the name of the overlapped actor. We have access to that actor. It's called other actor, and that will be passed in when this callback is called when the delegate loops through its delegate list and fires off any bound delegates. Now, in C++, we can get the name of an actor. We type other actor, we use the arrow operator because this is a pointer, and we can call getName. GetName, if we hover over it, returns an F string. So let's go ahead and store this in a local fstring variable. We can make it const. It's going to be an fstring, and we can call this other actor name and use the assignment operator to store the value returned by getName. And we can print this to the screen. Now we can add an on-screen debug message or use UElog. Either way, doesn't matter. I'm going to use an on-screen debug message for this. Now remember, we have to check gengine. If gengine is valid, we can access gengine and call add on-screen debug message. Now first we have the key. I'm going to pass in 1. Next we have time to display. I'll enter 30 for 30 seconds. For the F color, I'll use red. And for the string, we'll just pass in other actor name. That's passed in by fstring. Now notice the rest of these inputs have default values. If it says equals some value, then we don't have to pass that value in, as default values are programmed into the function, and that makes those optional. So I'm going to go ahead and leave out the rest of those inputs. And now we have some functionality in onSphere overlap. When something overlaps with the sphere, we are going to print that actor's name. So let's hit Save All and hop back into the editor, and we can hot reload this. So hot reloading, and after hot reloading, we can close live coding, and back in BP item, we now have a sphere component. It's called sphere, and if we select it, we can see its details panel. And by default, it's pretty small. We can barely see it here, but we can increase its sphere radius. So I'm going to drag that up until the sphere radius is a little bit bigger. I'll set it to 300. And now we have a sphere component, and we know that as soon as begin play gets called, our callback on sphere overlap will be bound to its on component begin overlap delegate. Let's see how this works. I'm going to hit compile and save, and we have an item here. We can press play and overlap with it. Now we're using an on-screen debug message, so that should show up right here in red, showing the name of the other actor, which is going to be our character, right? So let's overlap, and there it is. It says BP/character with those extra characters added on, the Unreal Engine tags on there. So we know that our overlap event is now working, and we're doing this from C++. So it's a little bit more work in C++ than it is in Blueprint, as we can simply right-click and get that on component begin overlap event. That's just built in. But in C++, we have the ability to create a C++ function. And this is a little bit more advantageous for us because we can do things in C++, access C++ variables that may not be exposed to blueprints, and we have more control under the hood of the game. So this is great. We now know how to bind callbacks to delegates, and we know that the primitive component type has lots of delegates built in. We took advantage of on-component begin overlap, and we looked at primitive component.h to see what the signature for a callback function needs to be in order for us to be able to bind it to on-component begin overlap. And we saw that this is the signature. It has all these input parameters. And by the way, these are the same inputs that we saw in the blueprint event for on-component begin overlap. We also saw that on sphere overlap, our callback has to be a U function because the particular type of delegate is a dynamic multicast delegate, which means it can be exposed to blueprints. Without the U function macro, our callback would not be bound. And we finally bound the delegate in begin play, as the constructor is too early. Not all the components are fully initialized yet. So begin play is the place to do this. And we bound our delegate with add dynamic. This is a function macro that belongs to the on component begin overlap delegate on primitive component. So with these steps, we created a callback function, and in response to an overlap, we're printing the name of the other actor, which gets passed into our callback when the delegate fires off all the callbacks in its delegate list. Great job. We now have the ability to do something in response to overlaps for our sphere component in our item class. I'll see you in the next lecture.